Welcome to the CBC 2025 changes to HCAI pre-approvals. We're waiting for a few more people to show up, so we're going to give everyone about maybe a minute here before we get started. You can download the handouts for today's presentation in the handouts section of GoTo. If you're using your browser, I believe it's under materials instead. I'll give it just a few more, maybe 30 more seconds here. Okay, we have passed the magic number. We are going to go ahead and get started. So again, welcome to the CBC 2025 changes to HCAI pre-approvals, ASCE 7-22 Chapter 13 webinar, brought to you by the Department of Healthcare Access and Information, otherwise known as HCAI. Today's presenter is Timothy Pyland, Senior Structural Engineer for the Structural Support Unit, and Roy Lobo, Principal Structural Engineer, will be joining us for the question and answer session. You may download the handout for today's presentation in the GoTo panel under the handout section, and if you're on your browser or phone app, it will probably be under your materials. Today we are scheduled to be here for 1.5 hours. We will start with the presentation and conclude with a short question and answer session. We ask that you please hold your questions until the Q&A session begins, at which time we will open the questions section of the GoTo panel for you to submit your questions. Please make sure that your questions are on topic and related to the material being presented today. If you have a question which requires a more in-depth answer, please email timothy.pyland@hcai.ca.gov. In coordination with AIA California, you will be able to earn 1.5 AIA continuing education units by attending today's presentation to the end. A certificate of completion will be emailed from GoToWebinar to registered attendees who logged in and attended the entire presentation. Multiple staff members from one office should have registered individually to receive separate logins for individual certificates. If you have questions regarding continuing education units, please contact AIA California. If you should experience transmission difficulties during the presentation, please log out and rejoin the webinar using the login information that was sent to you by GoTo. With that being said, once again, thank you for joining us today, and I'll now hand the presentation over to Tim.
Good morning, everyone. Welcome to yet another HCAI webinar. I'm Tim Pyland. I'm a Senior Structural Engineer here at HCAI. I'm working well into my second decade in the Structural Support Unit, specifically on pre-approvals. Those are OPDs, OPMs, and OSPs. Today's presentation is on the changes in the ASCE 722 as adopted into the HCAI pre-approvals. You're going to hear me say HCAI or OSHPOD. I'm going to use it interchangeably. I may use it in the same sentence. It means the same thing. For those who don't know, OSHPOD is the Office of Statewide Health Planning and Development, which is an office within the Department of Healthcare Access and Information. Anyway, they're one and the same. You may hear me say webinar and seminar because I've given this before, and so I want to make sure I'm trying to use the same terminology, but I may get a little tongue-tied on that one. So today's webinar is a technical webinar. Now, I say that with a grain of salt, more like a salt shaker full of salt, because if you're familiar with the pre-approval programs, this is nothing more than a review. If you're one of the project engineers or registered design professionals who use the pre-approvals on your projects, then this is going to be nothing more than a review. The changes from the 722 into the 2025 CBC from the 716 ASCE 716 is minimal, to be honest with you. I mean, there's actually only one new variable. All the other variables have different names and different values, but the reality of it is there's really only one new variable, and we'll go into all those variables. The other aspect of this presentation or this webinar is how we are going to adopt these changes into renewal and new pre-approvals to make the pre-approvals more project efficient towards the registered design professional who uses these on projects. Because the goal of the pre-approval program is to reduce construction cost. And so we're going to reduce the time that the project engineer needs to assess the pre-approval to be valid for use on his project. Well, then we've cut his time down. And we can also do that in plan review where you're simply checking capacities. And you'll see what I mean when I go into that in a few slides from now. So let me just go into it at this point. Here's the AIA continuing ed credits that Kelly talked about. You get 1.5 if you attend the entire presentation, and you can apply for those at the end. So this is the changes we're talking about is in equation 13.3-1, the F sub P. As you can see, it's used in table 13.5-1 and 13.6-1. I'm really only going to go into table 13.6-1, although I will touch on a couple of elements in 13.5. And these changes, they reflect a more refined approach of the behavioral response of non-structural components during major seismic event via testing and collaborative efforts by ASCE 722 Seismic Committee. Being that this is somewhat of a technical seminar as opposed to just a glossy overview of definition of terms, some of the slides are very verbose. And so if you try to read the entire slide while I'm trying to explain it, you will not benefit from it as much as you could. I've highlighted some of the font in red to draw your attention to that element of the slide. So if you just let me explain the slide as opposed to trying to read it, I think it's a win-win going forward. So as I mentioned before, the webinar will review the new horizontal seismic force equation F sub P within ASCE 722, Chapter 13, used in existing, renewal, and new HCAI pre-approvals, focusing on the design professional of record responsibilities. Now, there's two design professionals of records that we're referring to. There's the DPOR for the pre-approvals who submit the pre-approvals, and there's the project design professional of record. They each have different responsibilities. The pre-approval design professional of record will have added focus on pre-approval project efficiency by tailoring the pre-approval submittals to be user-friendly to the project design engineers. Okay, so throughout this presentation here, we're going to go through the changes for the seismic design force equation F sub P from 716 to 722, which are actually quite minimal. We're going to review the new variables within equation 13.3-1. We have comparison plots for some of the components in table 13.5 and 13.6 to see if the forces have gone up or down. To do a slightly comparative study, we have the application of the horizontal seismic force F sub P for both approval submittals and project use, which as I mentioned above, and we have examples for the OPM and the OSP pre-approval for the design professional record responsibilities. We're going to delineate what is required for each to ascertain the capacity of the pre-approval and the demand from the project. Okay, that's kind of what we're trying to do here. And these programs are listed in Pin 62 and Pin 55. So if you draw your eye up to here, it says pre-approval capacities for F sub P can no longer be determined by S sub DS and Z over H. For the ASCE 722, this equation over here, now you need the S sub DS and the H sub F over R sub mu. However, OSPOD decided to extend the requirements to the mass coefficient, C sub P. It's basically the acceleration component, which is opposite the mass of the component. So the C sub P is a fictitious variable we created for this presentation. You won't find it listed in ASCE 722 in Chapter 13. It may be listed elsewhere, but not in Chapter 13. We're using this it's a summation of all the components that make up the acceleration force, where force is equal mass times acceleration. So for the OPMs, it's all these coefficients other than the mass. Okay, for the OSPs, it's a tested design force coefficient. Okay, so it's the A flex horizontal, A rigid horizontal, A flex vertical, and A rigid vertical. So it's the tested spectral accelerations versus the analytical approach. Now, since we're specifying these, regardless of what changes are made in the 728, ASCE 728 or the 734 ASCE, it really makes no difference because the C sub P comprises all the elements which make up everything except the mass. The two between the OPMs and the OSPs, the CPM, which is for the OSPs, the OPMs, and the CPS for the OSPs are not equivalent to one another. One is an analytical value by using these variables here. The other is a tested spectral acceleration value where C sub AR, R sub PO, and I sub P is equal to 1. And I'll go into detail with that after a few slides here so you can see what I'm referring to. But you can't use the C sub P interchangeably. One is for supports and attachments in the OPM. The other is for special seismic certification of components. Okay. Here are the similarities between the two equations, 716 and the 722. Everything in the red box and the above and below are the same, which is kind of obvious. The I sub P is moved up to the numerator, but it still is reducing the overstrength of the R sub P. They've just moved it up into the numerator. The upper and lower bounds remained unchanged at 1.6 and 0.3. And you can see the variation between at grade and at the roof and how it varies in between over here. These are the changes. Everything in yellow is what's changed. So let's talk about the changes. So we have A sub P over R sub P is now C sub AR over R sub PO. Yes, they have new names and yes, they have new values, but they represent the same thing. It's the component amplification factor or the component resonant ductility factor. And the R sub P is the component response modification factor, and the R sub PO is the component strength factor. Same, I would say it's the same. The C sub AR and A sub P are similar as both variables possibly amplify the component response, the ability to achieve resonance. Okay, where the C sub AR is the peak component acceleration divided by the peak floor acceleration. It has to do with the component flexibility and the ratio of component to building period and the ductility. R sub PO and R sub P are similar in that both variables possibly reduce the component response, where R sub PO is a component inherent overstrength. And you can see as the building and the component coincide, how the amplitude goes up over here. That's just representative. The H sub F, we go back here, we have the H sub F over the R sub mu. We just went over the C sub A or the R sub PO. Now we're going to go over the H sub F over R sub mu. H sub F represents basically the old 1 plus 2 times Z over H. Well, now it's 1 plus 2.5 times Z over H. So it's kind of the same as it was before. There is another variation of it if you happen to know the building period. And here's an example where if you know the building period, it's to your advantage because it can reduce the maximum value of H sub F. Like this one where the building period is 2 seconds, the H sub F went from 3.5 using the default equation down to 2.46 using these equations here. Well, this is the lowest approximate fundamental period of the supporting building or non-building structure. Okay, so this webinar is related to pre-approvals. For the pre-approvals, we have HF sub max or max is 3.5. At or below grade, it is 1. That's going to come into play here when I show you the next slide. We're talking about R sub mu now. This is the new component. Okay, F sub P is now a function of the building seismic force resisting system. The R sub mu. R sub mu is a function of the response modification coefficient from table 12.2-1 or 15.4-1. Okay, and obviously the overstrength factor from the same tables. When it has to do with the ductility reduction factor, when the ductility of the structure goes up, R sub mu goes up, F sub P goes down. Okay, so if you look over here, you have a building That's concrete moment or shear wall rather, and you can see how the force is greater at the same period between that of a steel moment frame, which has more ductility. Now, this is just a common sense concept. The more ductile your structure, the less force the structure will attract, the less force that will go into your component. Okay, so as you increase ductility, your F sub P goes down. So a little bit more on the R sub mu. The R sub mu structural ductility factor is new. It's based on the building's ductility, as we just spoke of. Because this is for pre-approvals, the maximum value you can get for R sub mu for only one single force resisting system, and I'll show all the force resisting systems on the next few slides, is 1.71, but it's only for one system. The minimum value, if it's at grade, or if it's unknown rather, if the lateral system of your building is unknown, it's 1.3. If it's at or below grade, the R sub mu is 1. So for the pre-approvals, resulting in the H sub F or the R sub mu maximum is 2.69, which is above grade or at the roof. H sub F over R sub U minimum is equal to 1 at or below grade. So as a minimum, all pre-approvals must be certified for either one or both conditions dependent upon the non-structural component. Obviously, you're not going to put an 87,000 pound genset on the roof. So this one here above grade will not pertain. You will only have the one at grade. You can do intermediate levels, but these are the two requirements for the pre-approvals with regard to the OPMs and the OSPs. Okay, so for the supports and attachments and for certification of the component, we have to make these pre-approvals readily available for any structure anywhere in the state of California for project use. That's the intent, is to reduce the efforts by the registered design professional to use these pre-approvals. It should be readily apparent to them as to whether or not these pre-approvals are applicable to their project. So that's why we're putting these minimum requirements within the pre-approval. They'll be on the drawings or in the OSP document itself. They'll be on the drawings for the OPMs and the OSP document themselves. They'll also be on the application for the OSPs. Okay, so here's the different R sub mu values. This is where R sub mu is 1.3 to less than 1.4. These are mostly structures that have very little ductility, concrete moment frames or whatever. Everything in red are the special systems. Okay, I've just created this. You can see they vary. Some of them go up to 1.35 here. There's different variations. So as this is the minimum value, which is used by a lot of non-ductile systems. Okay, and here's the 1.4. It's less than or equal to 1.5 for the R sub mu. Now here you have steel special moment frames. You're going to be in this area a lot. This is 1.4. So if the OPM or the OSP is designed to the minimum and maximum values, you can use this to your advantage if you know the seismic force resisting system of your structure. Because you can, if it's a seismic moment frame, you can reduce the capacity, the demand rather, not the capacity, you can reduce the demand that your project will have on the component. Okay, so it's to your advantage to use the R sub mu for the building. If you decide not to use it, you have to use 1.3. So, and here's the R sub mu, which is less than 1.5, greater than 1.5 rather. You have a few systems in here. The 1.71 here is steel eccentrically braced frames, and you have special steel special plate shear walls, which is either a building frame system or a dual system, both coming in at 1.6 for this one rather. It's up here where you get the advantage. These are the top two, 1.6 and 1.71. Okay, so, and that's really the only significant change to the ASCE 722 from the 716 is the incorporation of the building lateral force resisting system. And it makes perfect sense to incorporate the structure that you're attaching the component within, because if the structure is going to damp out the forces, well, then less force is going to go to your component. So on this slide, we see that this is the old version, the 716, and this is the new version, the 722. You have the C sub AR now, which has two values, at grade and above grade. Well, that stands to reason, because at grade, the structure, the component is less likely to achieve residence than if it's in a structure. That's why it goes up if it's above grade. And it's stated here, where the addition of C sub AR, less than grade and above grade, is based on the component amplification at grade being typically less than the component application within a building. So it's going to hit residence, more likely to hit residence if it's in a structure. That's why there's two values here. And this is the old A sub P value here. Typically it's 2.5 and 6, and 1 over 2.5, which equated to about 0.41. Now it changes anywhere to 0.67 to 1.46. This is just introducing the two different columns for the old A sub P, which is the new C sub AR, and the logic behind why they separated the two values. Okay, this section. This is new. You have equipment, support, structures, and platforms. And then you have distribution system supports. These are both new to the 722. And I have to kind of go into detail on these over a few slides because it gets a little complicated when you determine the period of your structure, including the support and attachment, because that's what you have to do to determine whether you have four systems here for the equipment, support, and structures. Okay, and so in order to determine what area you're in, you need to know the period of the what I call the component assembly, which is the component plus the support and the platform. So what is a support? A support is anything greater than 24 inches for a piece of equipment. Distribution system supports now are separate from the design of the distribution system. Okay, so it's usually, if it's a brace system, it's 1 and 1.5. So let's go into equipment, support, structures, and platform in a little bit more detail. This is where it gets kind of verbose. So what constitutes equipment, support, structures, and platforms? Well, the commentary classifies it into three groups. Distribution supports are not equipment supports. So don't confuse the two. These are two different entities. Distribution support, this is equipment support. They're separate. This is equipment supports. Okay, so we're talking about equipment supports. Now, the three categories that the commentary breaks them down into is the first one, it's not a support, which technically is one of the three groups, right? So if it's less than 24 inches or equal to 24 inches, it's not an equipment support. So up to 24 inches is considered an integral support. I don't care if it's a lug, skirt, saddle, it doesn't matter. You have to design the connectivity between that and the component with the same C sub AR and the R sub PO that you would do the component. Okay, but anything up to 24 inches is not an equipment support. If it's over 24 inches, they break it down into two categories, although for all practical purposes, it gets the same C sub AR and the R sub PO. So it kind of is mute. It's the assembly of structure members that provide support for a piece of equipment or system, including the moment frame, brace frame, skids, and legs greater than 24 inches. Okay, and this is where I say the commentary also delineates equipment supports from equipment platforms, with platforms supporting multiple components or system, but the differences are inconsequential as both equipment supports and platforms have the same C sub AR lateral coefficients, so it doesn't really make any difference. Now, when you think of a support or a platform, you think of something supporting it from the base, right? Because that's just the natural, it's supporting it. However, if you look at this, let's go to these three different cases here. So this is the first one. It's 24 inches, so this is not an equipment support or a platform. I don't care if they're legs, lugs, skirts, doesn't matter. If it's up to 24 inches, it's not an equipment support. Okay, this is a suspended equipment. And if this is greater than 24 inches, this is considered a support. This is the integral support down here, which connects to whatever your component is. But this portion is considered an equipment support. This is going to make a difference in some of the OPMs. Okay, so, and this is the equipment platform, which is an obvious one. If it's greater than 24 inches, then it's a platform. Hopefully that's really clear. These two are the ones that we're talking about. This is not an equipment support platform. So now we go into the different categories for the equipment, support, structures, and platforms. There's four you can choose from. First one deals with the component, the T sub P. Okay, so let's talk about what the T sub P is. It's the fundamental period of the component, including the support and platform and attachments per section 13.3.3, i.e., we call it the component assembly. If it's greater than 24 inches, then the entire assembly period is what you're trying to determine. And if you have a component which is flexible, I don't care how rigid your support is, the entire component assembly is going to be flexible. It's not going to be rigid, no matter how you look at it. And this is the approximate fundamental period of the building. So you look at this first section here, and I'll go into all these different categories on the next slide. But it says the component, this is a note that I added here, 13.3.1.3. It says the component resonant ductility factor for mechanical electrical equipment mounted on equipment and supporting platforms shall not be less than the component resonant ductility factor used for the equipment support structure or platform itself. So the translation is, if a component is attached to a support greater than 24 inches, the component C sub AR must be greater than or equal to the support platform. Okay, that's what that means. So now we have the 4 different systems, and we have the fundamental period for the component assembly, or the fundamental period for the building and the component assembly, T sub P. So let's talk about T sub P for just a second, because this is going to get a little complicated. We'll accept any version of what you submit if you provide a basis, but it has to meet some logical engineering approach in order for us to accept it. So this is the period determination of a component assembly. The fundamental period of the component, including supports and platforms attachments per section 3.3. I mentioned this on the previous slide. It's component assembly. The component period is not a function, nor is it related to C sub AR. It used to be that, if your A sub P was 1, your component was considered rigid by some people. And it's like, that has nothing to do with whether the component is rigid or not. The component, okay, so the C sub AR, which is the component resonant ductility factor, ability to achieve resonance. So in the commentary in 13.3.3, the component period states in part, the fundamental period, T sub P shall be determined by the typical period equation. Further stating, provided the component supports and attachments can be reasonably represented by a single degree of freedom, spring, and mass system. I can tell you for sure that active and energized systems typically cannot be modeled this way. You just can't do it. Now, maybe perhaps for shelving, but CT equipment or other components that are in both the OPM and the OSPs, you may be hard pressed to prove that it's a single degree of freedom, spring, and mass system. So then how do you determine it if you can't do this? Well, the commentary further states, determination of the fundamental period for an architectural, mechanical, electric component using analytical or test methods is often difficult. That's what I was trying to state up here. And if not properly performed, may yield incorrect results. So if you're going to submit something like this, that has to have a good basis for us to, first of all, accept it and review it, and we'll see what the results are based on your basis. Okay, further stating the resonant frequency search procedure, such as that used in AC 156, may be used to identify the dominant mode's vibration of a component. Okay, so you can determine the natural frequencies of a component if it's shake table tested. That's a given. I added this down here, the supports used because we're talking about supports and periods and all that. So if this is for special seismic certification, if you have equipment on support, which is greater than 24 inches, so it's classified as support, and you shake table test it, okay, the support and the component are deemed to meet the lateral force requirements for the equipment, supports, and platforms. The attachments, however, must still be designed according to table 13.6-1. So if your component is on a support and you shake table test it, that connectivity between the component and the support, as well as both pieces of equipment, are seismically certified to be installed based on the AFLEX accelerations that the component was tested to. So you don't have to worry about the support if you shake table tested it with the equipment. So we go into the 4 different 4 sections. First one is 1A and 1B. So we've seen this before on the 2 slides back. We have the component assembly over the building period. So what this says is, if the component assembly period is less than 20% of the building period, then you can use C sub AR and the R of 1 and R sub P of 1.5, which is this. If it's in a building, if it's at grade, you can't even use this section for the building, obviously. Now we're talking about T sub P. This is the first section we're talking about. So this is 1B, the footnote 1B. Is a component is within a building or structure, and the component assembly is rigid, then you can use the C sub AR1 and the R sub PO 1.5. Using a support and platform designed using Chapter 14 material standard. Okay, so like I was saying on the previous slides, this condition is going to be very difficult for active and energized components and for a lot of the OPM equipment that is used to be anchored if it's in the OPMs, if in fact it's on a support. You're going to be hard pressed to get the entire assembly to be rigid. Go to number 2. 2 has 2 sections. These are the R values. Must conform to table 12.2-1 for both of these conditions where you have an R greater than 3 and R less than 3. And you have different values over here for at grade, above grade, and the RCPO. So to date, equipment, supports, and platforms designed using seismic force resisting systems from table 2.1 or 15.4-1 for pre-approvals are rarely used. They're used on projects, but not within the pre-approvals. Typically, I won't say everywhere, but majority of the time, you will not do this. It's way too expensive. I've seen it once or twice on projects where they have a genset, and they've actually used a braced frame to support the genset designed from tables 12.2-1. So if your component assembly is not rigid, and you're not designing this platform based on 12.2-1 or 15.4-1, then you're going to be here. That's the only system left. And that is 2.2 and 2.8 for your C sub AR. So you get an additional 120% and 180% added to your lateral force equation. So in stating that in words here, the component is flexible, regardless of the equipment, support, and platform and stiffness. The entire component assembly is flexible, like I stated 2 slides ago, and must use other systems using a support and platform designed in Chapter 14. So the supports, you're probably going to be in this area here. Here's an example. There's other examples. This wasn't the best one, but it's the one I had. This used to be a video, but it didn't lend itself to a PowerPoint presentation. So you have a rigid support. It doesn't look like it's rigid, but it is because it mirrors the shake table if you see the video. And this is a flexible component. So the entire assembly is flexible. As a result, you have to use the other systems within table 13.6-1, the 2.2 and the 2.8. This is for the design of the component connectivity to the support and the design of the support to the structure and the design of the support itself, actually. This may apply to computer racks, because computer racks are nothing more than supports, suspended and supported components, i.e. mobile lighting fixtures, X-ray booms, etc. So this is a significant increase for the supports. Now we talk about distribution system supports. These are new. So there are 6 different categories. 4 of them are bracing. They're bracing, it's 1 and 1.5. Other than bracing, it's 1.8 at grade, 2.2 above grade. It's pretty simple. The bracing is designed for the distribution system, separate from the design of the distribution system. The distribution systems have their own C sub AR and R sub PO values. How you design the support, it shall be based on the weight of the distribution system tributary to the support. You don't use the C sub AR or the R sub PO for the distribution system for the support. Support has its own C sub AR, excuse me, and its own R sub PO. That's why I put this note here. The design of distribution system supports is now a separate design from the distribution itself. And you can look up these sections for specific requirements. Oh, I just added this slide because the 722 will incorporate the SDS percentage increase across the state of California. And you can see from this picture that was given to me by Dr. Hussein Bhatia that the majority of the cases they've gone up. So make sure you incorporate the new SDS for your specific site for your project. This is for the project design engineers. Okay, and you just need to go to the HAS tool and determine what your SDS is for the site. So now we're going to go into comparisons between the 716 and the 722. It doesn't always look this grim. Okay, so this is mechanical electrical components. This plot over here is using two different values. Excuse me, it uses the old value for mechanical electrical components, typically air-side HVAC units and motor control systems as an example. So the C sub AR is 1.4, the R sub PO is 2. In 716, it was 2.5 and 6. Now I just used a random SDS value of 1.6. Excuse me, and a Z over H is equal to 1. The I sub P is 1.5. And for this, I show the R sub U varies across the bottom. And the T sub A for the building period varies. And it varies here down to where you get to the previous code, which is the current code, which is 716. So a T sub A of 2 is this bottom purple line here. And as the period gets smaller, it goes up to the default equation where your H sub F is using the default value. So for mechanical and electrical components, if you're in a moment frame and you don't use the building period, you're going to be here because it's an R sub mu of 1.4. And this is the default value for the 722, the force level, compared to the 716. If you don't know the lateral system, or you have a lateral system which has very little ductility, you will be over here. So this is a significant increase, but do not despair. So this is why this verbiage is here. It says on projects, do not simply compare the approval SDS to the project SDS. Other variables such as H sub F over R sub U may reduce the project demands. This is more prevalent on the plots I have on the following slides. It's not so prevalent here. Or use of a hybrid required response spectrum for OSPs may allow for the project use of pre-approvals with higher SDS levels. Okay, and I'll go into what a hybrid required response spectrum is when I get to the OSPs. So I've got a few more here. Here's mechanical electrical components. This is medical imaging equipment. Here's the 716. Here's the 722. So forces have gone down. So at this point, I need to interject that, and this is directed towards manufacturers. I don't know how many manufacturers we have attending today's meeting, but it is in your best interest to renew your pre-approval to the current code. For one, it's more readily usable by the registered design professional on projects, who is basically your client because they're buying your product. So with the C sub P value that I talked about earlier, that's going to be listed on the pre-approval, and the design professional of record will simply calculate his project demand, which is the C sub P for his project, and he'll compare it to the capacity C sub P of the pre-approval. The second reason to upgrade all the pre-approvals, the OPMs and the OSPs, is that for this reason right in front of you, some of the forces go down. So it's in your best interest, because the code level is less restrictive on the newly adopted code. You can use it for 716 project, for 2022 project, which use 716. The typical methodology is the authority having jurisdiction, which in this case is OSPROD. If the code is less restrictive on an upcoming code, and we've adopted that code in its entirety, or at least in this part that we're referring to, then you can use that on current codes. I mean, why do we have to wait till January 1st of 2026? The building doesn't care, right? The components don't care. They're just sitting there waiting to be installed, either half-inch bolts or 3/8. distribution systems are like, do we need another support or not? It doesn't really matter. So you can use it on the 2022 codes. So it behooves all manufacturers for those two reasons I just stated to update or renew all of your pre-approvals, both the OPMs and the OSPs. It will be to your advantage. So let's go through a few more slides here. Here's one where we have the seismic coefficient mechanical components for vibration isolated and internally isolated. These are spring isolated systems. Again, if you have a 1.4, you're going to be right here. I use a special moment frame as an example. If you don't know what it is, it's gone up significantly over here. But if you upgrade your pre-approval, for one, it will meet the current code for the 2025 CBC without any complications by the design professional of record being confused as to what capacity the old version of the pre-approval was designed to, because it requires an extra step for them to do that if they have to go back to a previous version, the 716 code, for an OPM that's designed to the 716, there's an extra step they have to take to determine its capacity. If you update it, there is no extra step, so it'll expedite the entire process. This happens to be for neoprene and suspended, vibration isolated. You can see where this has gone up as well. This is for distribution systems, happens to be copper pipe in accordance with ASME B31 by welding or brazing. You can see how this has dropped. Has dropped tremendously. These are the distribution systems themselves. So it behooves the manufacturers to renew their OPMs, the distribution OPMs, to take advantage of this and to use them in the current code. Let's see, this is scheduled pipe by thread and bonding. You can see where they're about the same at 1.4. So that's a push. You have duct systems included in this. I didn't go through all of them. I just went through a few of them. And this happens to be the distribution system supports. You can see how the supports now have gone up. So although if I go back here and look at the distribution system, the spacing will increase. You'll make or decrease rather. You'll be able to make or increase rather, but the supports will be farther apart because there's less demand on the distribution system. And then the supports will have a little bit more robust, but it may be a balance by the time you determine the load to the support itself, because on the existing pre-approvals, they've already been designed to a higher value. And this is, I picked one from 13.5-1, coefficient for architecture components. These are partitions. Now they're separated into less than 9 feet and above 9 feet. And you can see if you don't take account for the building period here, they increase for less than 9 feet, and they significantly go up for partition walls, which are in moment frames, maybe twofold or so. So this is a significant increase. So we have the adaptation, excuse me, my voice seems to be falling apart on me here, the affected OSPOD pre-approval program. So for the OPDs, there's 1, 2, and 3. Those are in-house pre-approval programs, and we're going to do those in-house and redistribute them out on our website so everybody can use them to the new code. We only need to concern ourselves in this webinar with the OPMs and the OSPs. Okay, and as stated below, the OPDs are being updated. So, can you use the existing pre-approvals for 2025 projects? Yes, you can. You don't have to do anything. The only one you can't use is an OSP, which is expired. Everything else is fine. You can just leave it alone. You don't have to change anything. So the existing OPM pre-approvals are valid for any project, regardless of the CBC version. Renewal and new OPM pre-approvals for the 2025, however, require updated calculations and drawings revisions reflecting the current code. The OPM will have a new updated application, which we should have on our website by July 1st. That's our goal, is to get the updated application for the new OPM pre-approvals. The existing OSP pre-approvals, which have not expired, are valid for use on any project, regardless of the CBC version. Existing shake table tests are valid on any projects also. the renewal and new OSP pre-approvals will require an updated application that'll list the C/P values for the OSPs, which is the horizontal accelerations, A flex horizontal, A rigid horizontal, and the other two for the vertical. Okay, the existing OPD approval is valid for use on any project. You just have to calculate the capacities. So I'm going to go into how you do each one. It's fairly simple. It's all simple. It's just that it's easier if your pre-approval is updated to the current code. I can't stress that enough. It makes life so much easier. And it may be, well, it is to your advantage with regard to the registered design professional using your updated pre-approvals, but it's also to your advantage in fact that if the forces go down for the new code, you can use them on the current code. So we talked about this before. There's two design professionals of records, and we're going to talk about their responsibilities for each one. We have the pre-approval design professional of record who submits a new or renewal approval, pre-approval to OSHPD, and we have the project design professional of record who submits the pre-approval for project use. They may be one and the same. They may be the same person. But for most part, they're kind of different here for people. So let's go into the OPMs. This is for the supports and attachments of equipment. The idea is to reduce construction costs. So that means expedited use of the pre-approval. If the design professional of record for the project has a difficult time ascertaining what the capacity is of the pre-approval, it slows down his time, causing increase in cost. We don't want to do that. We want to reduce the effort. That's why we're encouraging everybody to update your pre-approval, your OPM, to the new code so it's readily comprehensible to the design professional of record for the project to use that pre-approval on his project. So how do you use an existing OPM for the 2025 CBC? Say it wasn't updated. You have to use the existing one. So what the design professional of record has to do is go back to the 716 equation. If it's not listed on the OSP, or the OPM rather, OSP, OPM, if the C/P is not listed, in other words, the capacity to which the OPM was designed, then he has to go back in and calculate it based on whatever variables were put in for that OPM. And then from there, he calculates the 2025 CBC project demands. And the project demands must be less than the F/P capacity for the pre-approval. So that's an extra step the registered design professional has to take if, in fact, you have an OPM which is not designed to the current code. If it's designed to the current code, they're going to be required to list that capacity, and you can readily check this, but just by observation. He still has to calculate his project demands. That's neither here nor there. That'll always be there, but you want to make the pre-approval more efficient. So the OPM design force coefficient for both the pre-approval and the project must be listed on the project calculations. And this is the design professional of record submittal responsibilities, by the way. I forgot to mention that in the beginning. So the coefficients for both pre-approval and project must be listed on the project calculations so we can readily comprehend whether or not it's valid for use on your project. However, it may also be included on the construction drawings, although it doesn't have to be, to possibly reduce an amended construction drawing. Say they make some modification in the field. Now you know your capacities for the pre-approval and you know your demands for your project. And someone in the field could easily check this and approve it. So it reduced an amended construction document to a non-material alteration, saving time and cost. Okay, this is for use of an existing OPM and design responsibilities for a project design professional of record. And this is how you would do it. Use of an existing OPM. This is an example. Pulled this off our website. It's public information. This is designed the 2022 CBC, but the 716 ASCE. So they would go in here, determine these values. Now, if this one happens to list the coefficients over here, not all of them do this. So you'd have to go in here using these variables and determine the capacity of this pre-approval for the condition which it is designed to. Okay, and then compare it to your project demands. Okay, as I stated, the OPM design coefficients may already be listed. Some of them do, some don't. It's hit and miss. So this is renewal update or a new OPM 2025. So the component design force coefficient, C/P. We call it CISA PM for the OPM, CISA PS for the OSPs. CISA PM is simply the FCP over WCP, which is all these design coefficients that are in red here. This must be listed on your pre-approval, your OPM. So it's readily comprehensible by the project design professional of record to compare with the demands that he has for his specific project. For each different configuration, you're going to have a CPSM or CISA PM rather. Okay. These are additional requirements for the submittal design professional of record. You need the CISA PM for both FCP, WP, and FCB, WP. You need to list the SDS, the ISAP, the CISA-AR, all these variables. Updated or added anchorage forces, T sub U, B sub U, and specifying whether or not omega was used for each different component configuration. Okay, so you're going to have one at roof, maybe. You're going to have one at grade. You may have different mounting configurations. For each different configuration, you need these variables listed. So the design professional of record can come in and look at it and go, I have this condition. This is the capacity for this OPM for this condition. Here's my project. I can readily compare it and use it on their project. Okay, as a minimum, A sub F over R sub U must be listed for above grade at 2.69 and or at below grade at 1. Specific intermediate building elevations and seismic force resistant systems only are not allowed. You have to use this maximum value and minimum. You can use others, but you can't just list specific systems, okay? Because it may be overlooked during design or installation or future equipment relocation. If you have KBs and you need to, or TZs and you need to change it to TZ2s, you need to do that as well. You need to update the anchorage capacities to the latest ICC ESR version. Don't leave old standards on these pre-approvals. Please update everything so it's current. Update all listed reference standards. And we need, along with the submittal, we need manufacturer's cut sheets depicting the model number, configurations, dimensions, etc. used within the OPM. Catalogs may be provided, but only for the units included within the pre-approvals, depicting the cut sheet. Don't send entire manufacturer's catalogs. They're huge. We don't like looking through them. This is the additional requirement in addition to those up here in red. Here's an additional requirement. We have an additional top-sided post-installed anchor configuration and drawing. Okay, top-side only post-installed anchor configuration. That's what we're trying to do. The reason we're doing that is because through bolting increases construction cost. And we're trying to get away from using through bolting. It creates contractor change orders and greatly increases construction. So it may not be applicable in every condition. We realize that. Okay, that stands to reason. If applicable and within reason, to the design professional of record for the submittals, add concrete over metal deck component anchorage using the top-sided only post-installed anchor connection as opposed to through bolts, if it's applicable and within reason. Reducing the OPM design force FCP, albeit within means, is what I'm trying to say here. An SDS at 0.25 serves no purpose, so that makes no sense. Okay, you can achieve this by providing additional supports and attachments. May redistribute the component attachment forces if you modify the support and attachment. Using larger post-installed anchor, possibly, you can only get them so big. Changing the mounting configuration if possible. And if this is omitted, then give us a written valid basis within your submittal so that we can go, yes, that makes perfect sense. They obviously can't do it here, but at least you made an attempt. Intended to reduce project change orders observed through bolting. And it reduces the labor cost associated with through bolts. So that's another requirement for the design professional of record submitting the pre-approvals. Additionally, although not required, you can have both versions listing ASCE 716 and 722 versions. You already have the ASCE 716. And you could put one, typically would be the 716, in an appendix. So they're approved for both codes. You don't have to do this. Excuse me, you don't have to do this, but you could. How does the project design professional of record, what are his responsibilities? Well, he calculates his project 2025 CBC project demands and he compares them to the capacities. And if he's using a new or renewal updated OPM, well, then the capacities will be listed on the drawings and he'll be able to easily comprehend whether or not he can use this pre-approval on for his project and his installation condition. And again, the OPM design forces for the project design professional of record needs to be on the project calculations. And you can also include them on the construction drawings if you want, possibly reduce the amended construction document to a non-material alteration. And this is the renewal update or a new OPM, how you would use them. You're going to list all these variables, as I mentioned before. The CSP is the most important one, the CSPM, because that's what the design professional of records can readily use to determine whether or not the pre-approval is used for his drawing. That's why I tell the manufacturers, if you can renew your pre-approvals to the current code, it will serve you well. It is in your best interest to do this. You're going to be, it'll work for the current code. It'll work for the new code. The sooner you do it, the better off you'll be. It just makes it more readily usable by the design professional of records, which are your clients. It just makes good business sense, actually. So you would update and add the OPM design tension and shear forces. You would update the OPM design coefficients, update OPM design force coefficient to the 722. This is the variables over here, but he has them listed in two different places here, so you'd update those. And then if needed, you revise the attachments and the supports. Okay. So now we go into OSPs. Okay, so this gets kind of down into the weeds a little bit, but it'll allow you possibly to speak somewhat intelligently about the demand, the capacities of your OSP compared to the demands on your project. Okay, for those of you who submit these pre-approvals, this is nothing more than a review. This is nothing. You've seen this 1,000 times. It's in every test report, and I've looked at test reports for well over a decade. So, the OSP pre-approval. The OSP is the tested component design force coefficient, C sub PS. It's used to is defined using a very simple method. The F sub P is equal to this C sub PS value times the mass, where the R accelerations, required response accelerations, C sub P S is the tested component design force coefficient. It's basically the coefficient to the mass, which you've shake table tested. The RS values are already listed on all UUT sheets. So they're already there. You just have to revise the application and perhaps your certified component tables and your certified subcomponent tables, if in fact you're still calling, if in fact you're calling out the S and DS and the Z over H, it needs to be more in line with the C sub P values, which are the accelerations for the component. Okay, so this is the two-period design response spectrum. Everybody's familiar with this. For shake table testing, that's why at the very beginning I said the C sub P for the OSPs and the C sub P for the OPMs are different. They're not the same. And the reason is the C sub AR and the R sub PO is equal 1. And that's because the amplification, you don't add a factor here because the component, when it's on the shake table, will either be amplified or it won't. And the overstrength for the component will either have the overstrength or it doesn't. It's a result of the test. I sub P is a measure of the component's functionality. So the component is either going to function after the shake table test or it's not. So the I sub P is equal to 1. So these are all equal to 1. That's why you can't compare OPM C sub Ps to OSP C sub Ps. It doesn't make any sense. And I go through the normalized response spectrum accelerations with AC 156. This is taken directly out of AC 156, where you say 40% of the peak spectral design response acceleration is an accepted approximation to the peak ground acceleration at 0. And this is right here on this 2-point spectrum. This is the 40% spectral design response acceleration, which is compared to the 0 period ground acceleration. Then the SDS, which is up here, which is the A flex horizontal, is the peak spectral design response acceleration at 2 seconds, which is in the flexible region. This is in the rigid region over here, and this is in the flexible region here. And I'll go into that on a couple of slides to where it's more comprehensible. It results in the 2.5 times the peak ground acceleration equates to the peak response acceleration. So there's your correlation between your design response spectrum and the peak ground acceleration. These are the equations used in AC 156. It's basically this equation right here brought in for A flex horizontal, which is up here. And I'll show you, it's more obvious when I show you on the next slide. But the equation is 2.5 times 0.4 times SCS. This equation, this 0.4 times SCS is the same 13.3-1 equation in ASCE 722. Okay, you have the A sub F over R sub mu, the C sub AR, the R sub PO is 1, the I sub P is 1. It's the same equation. What they do is they cap it so you don't get the peak here where you normally see a 0.5, when you see the 0.5 or 5% damp spectral response, yeah, you'd see a peak here. Well, they cap it at 1.6. Typically, all shake table tests are tested to this cap. And then for the rigid version over here, you're going to use the 2.5 is no longer pertinent. So the 2.5 times 0.4, that's equal to 1. That's why the SDS is here. Over here, there is no 2.5 because it's 0.4 SDS, and it's just A sub F over R sub mu. It's a function of both the height and the ductility of the structure, the R sub mu. Vertical response is, since the 91 UBC, they've done this. It's 2/3 the horizontal. Z over H is equal to 1. The A sub F over R sub mu is 1 because it's vertical. There's no vertical acceleration within a component, right? So it's just 2/3 the SDS. And for a rigid vertical, it's 0.4 times 2/3 SDS. Okay, so this gives you kind of a background. If you've been doing shake table testing, this is nothing more than review. If you're not familiar with it, this may be a little perplexing. So now we go, this is the one-stop shop plot. It has everything you've ever wanted to know about shake table testing is right here between these two plots. So this is the required response spectrum. This is what I've been talking about the entire time for OSPs. What you see in yellow are the maximum values possible in the state of California to the code. Okay. The only thing that's reduced is a rigid horizontal, gone from 2.4 down to 2.15 right here. Everything else is the same. And at grade, this is at grade, this is above grade, this is all the same. So if you look at this plot, if you're not familiar with it, this is in Hertz. This is the way the shake table test spectrums are plotted. It's inverse to period. So everything is reversed. You have the flexible region on the left, rigid region on the right. The maximum value you can get is 3.2 because it's 2.0, which is above grade. So it's the 1.6 times 2.0, which is the 3.2, which is this value. The H sub F over R sub mu, taking a maximum value, is 2.69. And for the vertical, it's 1. And the C sub AR, R sub PO, and the I sub P is 1. You'll end up with this plot. Here's the 716 on the lower end, and here's the 722 on the top. You can see that they're very similar except for this. The 722 is less restrictive than the current code. Okay. So again, it's to your advantage to use the new code. This is the horizontal motion. This is the vertical motion. This is at grade. At grade, you increase the SDS if you want to test it to the maximum value, because now you're at grade. And 2.5 is the maximum in the state of California. With the increases in SDS, as I pointed out earlier, I think there's one facility up in Northern California that has an SDS of 2.37. So 2.5 is greater than what the maximum facility we have currently on record. Okay, the H sub F over R sub U is 1. All these R sub PO, C sub AR, I sub P is equal to 1. This is at grade. Here you have the horizontal, and here you have vertical. Again, flexible and rigid on the right, flexible on the left. Components, this is, oh, I'll show you that on the next slide. if you want to test your component to the maximum possible acceleration in the state of California, you do what's called a hybrid spectrum. You test the horizontal here, and you test the vertical over here. All you do is increase the vertical acceleration. And then you have a hybrid spectrum. You have 3.2, the 2.15, and then you have 1.67 to 0.67. If you have that and you see that on an OSP, you can use it anywhere in the state of California. There's really no exception. Okay. So, and some people do that, some people don't. You can see that the vertical over here is 1.33 compared to the 1.67 here. This 2.5 is less than the 3.2 here. So a hybrid spectrum is the horizontal above grade, the vertical at grade. So now let's look. So I'm going to take this horizontal motion right here, and I'm going to plot it on a 2-point spectrum. And it looks like this. It's over here. So here's the horizontal motion, 3.2, 2.15, and here's the test response spectrum. That's typically the reading from the accelerometer in the center of the table, which is the applied acceleration to the component. And this is what it's required to eclipse. It's the required response spectrum. Okay, and so if you plot it over here, you have to inverse it. This is in hertz, this is in period. This is what you're normally used to seeing. So you have a 5% damp spectrum response and a 2-point spectrum here. Now I just put one in here. Yours will obviously change depending on your project, but you can see what's happened here. You have the flexible region on the left, rigid on the right. Now the rigid is on the left and the flexible is on the right because it's flipped. And typically your components are tested between this, from this period, this is like 0.76, 0.77, down to like 0.1, right? That's this range right here. Components will achieve resonance in this range right here. There, I have yet to see one that shake table tested that hits resonance out in this area. So you're going to be in this area when you design it, and you can see where the 3.2 compares to the 5% damp spectral response or the 2-point spectrum, how it now applies to these spectrums. Typically, if you're used to seeing this, you rarely see this happen. When I saw it, I thought that clouds would part and the sun would shine, but it didn't. Just okay, well that makes sense, right? I've been looking at this for so long. Anyway, this gives you a background on where the required response spectrums come from, right? And you can relate it to a 2-point design spectrum, a response spectrum, which is used in the design. So it just kind of gives you a background on that. So how do we use existing OSPs? The existing OSPs, and this one happens to show a hybrid response. It's 2.0 above grade, and it's 2.5 for the SDS at grade. And so you end up with 3.2, 2.4, 1.67, and 0.67. If it has this on the OSP, you can use it anywhere in the state of California. So if you want to know what the capacity is for this OSP, the F sub P would be the A flex accelerations times the mass. And if the design professional of record wanted to know the capacities that's required for his site, his A sub F over R sub U will be less. If this isn't maxed out to the maximum possible, he can compare his to the current, the OSP he's trying to use, and he calculates his using these equations here. You substitute the SDS, the A sub F over R sub U, and these equations, you're going to end up with these 4 acceleration components, of which you can calculate the F sub P horizontal and the F sub P vertical. So your project has to be less than those that were tested, the capacities. Okay, so that's how you would test. That's how you would check an OSP to your project, if in fact you needed to do it. It used to be we just go the SDS and Z over H. Now there's other variables. The H sub F over the R sub U comes into play. So this is the way you would check it. This is the final slide because there's confusion with the current OSP application. The current OSP application lists the F sub P over W sub P, but that is a reflection of the supports and attachments used for the OPM. It's not the A-flex horizontal values. Okay, so don't confuse the two. If you're using an existing OSP designed to 716. Again, would be for the OPM if you want for the sports and attachments, if you want to use it for that, or you can come up with your own values, whatever as long as you provide a decent basis. And this is going to be modified. We're going to have a 2025 CBC OSP application, which will change these parameters here. Okay, so that's, oh wait, we have the new ones now. That was the existing. So the new ones, we have the project design professional of record responsibilities. So he's going to come over here. I'm anticipating this will be changed on the OSPs. It will now reflect the R sub mu and the H sub F. It could be one column, two column, whatever. It should be something other than the Z over H, which is used here. You should list the R sub mu and the H sub F. And then you're going to have a revised value. If in fact you've tested it to the maximum capacity, this will be less. Okay, so for the component tested capacities, again, you have the accelerations, you have your mass. You can determine what the tested capacity is. And then the project design professional of record, if in fact he needs to check this, he can use his values, substitute them in these equations, and determine the demands for his specific project, which must be less than the tested capacities. So the updated application, which we should have online by July 1st, we're revising it now. We have to get IT also involved so that you can select whether it's 716 or 725. We're hoping July 1st that'll occur. The new application, you will list the C sub PS for both horizontal and vertical forces, which is the accelerations, and the corresponding SDVS, H sub F, R sub mu, and I sub P. Along with that, you need manufacturer's cut sheets depicting the model number, configuration, dimensions, etc. As used with the OSP, catalogs may be provided but only for the units included within the pre-approvals. Don't send the entire manufacturer's catalog because we don't want to go through everything. And then the other submittal requirements as listed in Pin 55. And that's kind of the summation of everything. And if you need to email me any questions, here's my email address. Okay. Kelly?
So we've now opened the questions section of the go-to panel. Please type your questions and we will answer as many as time permits. Again, please make sure that your questions are on topic and related to the material being presented today. If you have a question which requires a more in-depth answer, please email Tim Pylan directly. So we're just going to wait a few minutes, let people start going into the questions panel and asking questions, and we're going to start reading them and answering your questions.
Okay, so this first question is by Matt Brown. If we get an OPM renewal approved prior to January 1st, will the authority having jurisdiction, the LOSHPOD, accept that even though the 2025 CBC hasn't been adopted yet? So the renewal, you didn't say whether renewal would be to the current code or the new code. We'll accept either one, but after the first of the year, we will only accept the new ones. So hopefully that answered your question. And a lot of questions here. So let's see. Pre-approval. Okay, this question is by Brian Akers. Pre-approvals will utilize 7.22 over 716 around July 1st. Yeah, we'll utilize them now. Unfortunately, we don't have any that are approved for the 2025, but that's the idea is July 1st. We'll have everything online so you could submit your application and it'll tell you 716 or 725 and you select the 725, you'll go into the 725 application and you're required to list, fill out the application, obviously. And then the drawings for the OPM should list those variables as I stated in this presentation. After January 1st of 2025, the 716 version of the 2022 code will no longer be available. So let's see. Okay, this is from Gillian. I work with Gillian a lot. So let me see this whole question because I can't quite make it out. What is the deadline to submit newer renewals of existing OPM, OSPM? Well, okay, just December 31st would be the last day that we would accept it. Because we're enforcing the new code January 1st, 2026. Should be rated grade 6.7. Any value be used and then so to answer Ryan's question, I know most of these people. To answer Ryan's question, that is yet to be seen. Because if the UUT has an OSP for an OSP is shown to be rigid with the lowest natural frequency greater than 16.67 hertz, can the A-ridge values be used instead of the A-flex for project-specific applications? It would depend. I really can't. That would be a project-specific submittal, so I can't really answer that in today's presentation. Okay, so Dieter asked me over at CYS, say something about the Z over H ratio of 0.95. I knew you were going to ask that, Dieter. If in fact your component cannot be suspended from the ceiling area, from the floor above, and it cannot be installed on the roof, it's an interior hospital component for an OPM. You can, in fact, use 0.95 as opposed to 1, because that will allow you installation on the 14th floor of a 15-story structure, which will cover most conditions. Okay, and I didn't mention that in the presentation, but that was a very good question. And checks in the LPD. Will we see similar? So this question is from Nathan Joe. Will we see similar procedures for performing demand capacity checks for the OPDs? The OPDs, hopefully, yes, they will show you the capacity. It used to be based on the SDS and the Z over H. Now they will show a C sub P value, or that's the goal anyway. So it can be readily used by the design professional of record for projects. Such as a beam clamp. Okay, so Robert Simmons from down in Texas asked me, can you get an OPM for a discrete restraint such as the beam clamp or a particular restrained isolator? And the answer is isolator. We have done tests for isolators where they have OPMs, but typically the answer would be no. In other words, if you have an A35 framing clip, we're not going to test that and give you an OPM for it. And that's kind of where you're leaning with this question with a beam clamp. There's values for these beam clamps. They're typically established by ICC through an AC acceptance criteria. So we don't address that. What the OPMs address is the support and attachment of a component to the structure. So you have to have a component. Could you get a beam clamp pre-approved? You'd have to have a component which is being supported by this beam clamp, and you would determine the capacity of that, and you would present it in the OPM in that fashion. It would be for the component attached, this certain component, whatever that component is, and it would be attached to the structure using the beam clamp. So there is a way to do that. A beam clamp by itself, however, is not allowed. What we tend to generate for the application as far as listing CPM. CPM, Rachel Wolf. What should be done until, so this is from Rachel, let me know. What should be done until January 1st on OSP applications as far as listing the CPM? So I think you mean the C sub PS, because the C sub PM is for OPMs. C sub PS is for special seismic certification. So again, if you're submitting to the 716 code, you do nothing. If you're submitting to the 2025 code, well, then it's going to be on the application because it'll ask you for that value. and you would change your certified product tables and your certified subcomponent tables. Instead of saying the S to DS and Z over H, you would put the flexural accelerations, or not the flexural, but the acceleration, the C sub P S values. Okay, you're just substituting one for the other because of the R sub mu factor, which comes into play now. Let's see. Kenneth Lord, if I understood correctly, you mentioned that through bolting will not be permitted for equipment anchors and that you can reduce demands within reason. I can't read the whole question. That you can reduce demands within reason. Will there be a guideline within reason? A rational engineering analysis is the reason. Okay, if you can't do it, you need to provide a basis, some rational engineering guide. In other words, the SDS is 0.1. Well, that serves no purpose, right? So, or you need 1-inch diameter bolts, which you can't put in, concrete over metal deck application. I mean, something, a logical engineering rationale is what we're referring to. So guidelines, like, no, we're all engineers, so kind of that's the way you do it. The NOXP expires in 2028. Do you recommend to revise to 2025 CBC? Yes, I do, actually. You can just you don't have to redo the test. You just have to update the application and the product tables, because it can be more readily used by a design professional of record if, in fact, they need to determine whether or not that component, which has been shake table tested, can be used on their project. That may not be a relevant, that may not be an issue, because if it's tested at 3.2, et cetera, you can install it anywhere. But if it's not tested to the maximum values, it's to the manufacturer's advantage to update their OSP to the current code. Okay, that's what I was trying to stress during the webinar. Can we get a copy of the recording of this webinar? You're going to have to email Kelly on that one. That's Cesar Romero. You do have copies of the slides. I believe this webinar is posted. I'm not sure exactly where. You ask Kelly for that. Let's see, MPC 4D CDs, would an ACD be required for projects using nowadays? So for OPM specified in MPC 4D construction drawings, would an ACD be required for projects using outdated OPM? That's very project specific, so I'm going to defer that to an email, which I can answer. And then we have a question here for a distribution system support, pipe hanger with rigid braces hanging. Okay, that's a good question. Greater than 24 inches below, floor above. Do I understand correctly that the distribution system characteristics are irrelevant? Only the distribution characteristics are irrelevant. I'm not sure I understand that question. I thought you were going to ask something else. Let me expand upon that, see if I can get the entire question here. For a distribution system support, a pipe hanger support with rigid braces hanging greater than 24 inches. So in other words, okay, so, all right. So I'm assuming, do I understand correctly that the distribution system characteristics are irrelevant? I'm not sure what you mean by that. When I see something greater than 24 inches, I'm assuming you're referencing that to an equipment support and platform. Distribution supports are completely separate from equipment supports and platform. They're not the same. I don't care. You can make the distribution supports, 60 inches long. Doesn't matter. Okay. It's not equipment. That's for a distribution system. They're completely separate. Hopefully that answers your question. I'm not sure if it does or not. If not, send me an email and I'll answer it. Can we choose? Okay, this question is from, let me expand this a little bit. I can see it. I can't. So can we choose, this is from Carrie Mitchell. Can we choose the maximum C sub P we want to design to our 2025 OPM? Okay, so you're restricted by using the minimum and maximum values of H sub F over R sub U. What that results in with regard to your S sub DS would determine your C sub P. And your component determines the C sub AR and the R sub PO. So the H sub F over R sub U have two values that you must list if in fact you can install it in the structure, okay, as a minimum on your OPM. So can we choose? You can choose other values that you want, but as a minimum, you need those two conditions. Okay, again, we're trying to make this readily usable and comprehensible to the design professional record for the project. 40% increase, and this is from Tyler Dorner, excuse me. 40% increase in F sub P when you go from 9 feet. Okay, this is for partition walls, which are go from 9 feet to 9 feet, greater than 9 feet. And ASCE 722 for our temperature seems a little much. Why not more of a gradient versus a step function? I know you didn't write the code, but any comments? You know, it would be, in my opinion, it would be based on testing and research, which has been done in that area to determine that this is the value which appropriately reflects the response of a partition greater than 9 feet or less than 9 feet. That would be, I wasn't on the committee that did this. This is probably the ASCE 7 seismic committee that does this. So let me go to another one here. So we have Carrie Mitchell. Would a 36-inch drop hanger or trapeze on a distribution system count? No, the distribution supports and equipment supports are completely separate. Distribution supports are not equipment platforms. Okay, unless you're supporting an HVAC unit, then it would be. But if it's for a distribution system, no, they're completely separate. So this question comes from Ryan again. Guys, right, all the people I deal with every day. What is the AFLEX horizontal minimum requirement for achieving an SDS of 2.5 at 0 rate equal to 1? For either 73 compliance. Historically, we have seen 4Gs. We have seen 4Gs being required by OSHPD for OSPs. 4Gs, no, that's 2.5 at 0 rate equal to 1. You're not going to get that because the S to DS for 0 rate equal to 1 caps out at 1.6 times the SDS, which is 3.2, which again drops the SDS down to 2. So I'm not sure what is meant by that equation, or by that question, excuse me. And this question is for, let's see, hold on. Okay, so this is a good one, Nathan. Will a pin or can be published to clearly outline the procedures for using pre-2025 CBC OPMs and OSPs that you showed us today? We are going to incorporate these requirements into both pins, so it's something that's more readily downloadable and something you can follow as opposed to this webinar. This question is from Hey Song. Does the project design professional record also need to provide calculations for a new design force that complies with the ASCE 725 in order to utilize the existing? Yes, of course they do. You need to determine the capacity of your project to compare with whatever your existing pre-approval is. If I read that correctly. If I misspoke, please send me an email for clarification. Or if I'm reading the question wrong, please send me an email and I'll verify it. Can you get an OPM for platform frames now? Of course you can. You can, unfortunately, you can't submit it, but because we don't have that available till July 1st. So that's our goal, is to get everything online, up and running by July 1st. Okay, so this one's from Derek. I don't know where Derek lives now. Anyway, if we submit an OSP renewal under ASCE 722 with the old maximum RRS test values, SDS2, 0 rate equal to 1, what AFLEX and what A-rigid values will be valid for the 722? Okay, so what AFLEX will be valid? Okay, so right now the 716 values for the accelerations for shake table testing are more conservative than the 722. So you can list whatever the shake table is whatever the shake table is. You can list those values. You don't modify what was used in the test onto the OSP. It's simply a replication of what was tested. So and it's to your advantage to use the new code, but if you want to use the existing shake tables, which most people will, they're going to have higher values listed on the newer OSPs because they were shake table tested to the old 716 code or the old ASCE AC 156, which is a reflection of the 716. Okay, we're getting more and more questions. We're at 11:30 right now. Let me take one more here. So Mike Schuler, what variable is associated with 3.2 max shown in the chart? Okay, so that's the 1.6. I don't have the code in front of me or I can recite the section. I think it's, I want to say it's 13.2.6, or I'd have to look, but it's before the section 13.3.1. You'll go back and it's the testing alternative. It says that the maximum that in the 722, the maximum, well, it says it in the 716 as well. The maximum you can achieve is 3.2 times the I sub P, which 3.2 reflects the 1.6 times the S to DS. And the 1.6 is the maximum listed in 13.3-2 in the 722 or in the 716. Okay, so it's past 11:30 now, so I'm going to close this up. If you have additional questions, please send me an email and I'll respond to an email. Phone calls are kind of hit and miss. Emails are the best method to get a response that's in writing. I want to thank everybody for attending today. Hopefully I haven't confused anybody and made this presentation that perhaps you can use in your upcoming renewal of every possible pre-approval that we have on record. Thank you. Kelly.
This brings us to the end of our presentation. We hope you found this webinar to be helpful. Please remember, if you didn't download the PDF handout, you may do so now by going to the handouts or materials section of the GoTo panel. Alternatively, the slide handout will be available on the HCAI website in approximately 2 weeks. Also, today's session has been recorded and will be available on the HCAI website in approximately 3 weeks. If you have any questions about this presentation, again, please email Timothy Pyland at hcai.ca.gov. And it's been a pleasure being with all of you today, and thank you for doing your part in providing access to safe, quality healthcare environments throughout the state of California. Have a nice day.